Hi everybody. Here's a third example. X is a regular vector, regular coordinates 1, 2, -1 in R3, a regular plain old vector. We want to find the coordinates of X relative to the basis B, and B is a basis consisting of these three vectors. In other words, what we need to do is express the vector 1, 2, -1, because that's our vector X, in terms of these three vectors, first vector, second vector, and third vector. So it's going to be some scalar times the first vector plus another scalar times the next plus another scalar times the next. So really, I just have to find C1, C2, C3. That's going to be my coordinates. Or I should say my coordinates relative to the basis B. Well, if I multiply this whole thing out, I wind up getting three simultaneous equations with three variables, C1, C2, and C3, and I just got to solve them. As you know, there are many ways to do that. Here's how I'm going to do it. I'm going to rewrite this equation in matrix form, and I'm going to find the inverse of this big matrix here. Well, the inverse of the big matrix is -1, 3, 1, 4, -7, -2, 2, -3, -1. I'm going to take this inverted matrix and I'm going to multiply it times the column B. And when I do that, I get 5, -8, -2, and that is my C1, C2, and C3. In other words, X, the original vector X up here, 1, 2, -1, is equal to 5 times this vector, minus 8 times that vector, minus 2 times that vector. So the coordinates of vector X relative to the basis B is 5, -8, -2. Yay!